So in this problem, we will have a cube, and we want to find the rate at which its diagonal is increasing if its edges are increasing at the rate of 6.6 centimeters per second. So what we need to do is draw a diagram of a cube to get started, and then that way that'll help us to find the relationship between the diagonal of the cube and the edge lengths. So I'm going to draw a really large cube here. So there's the base. We have four legs going up. It's going to look something like this. Okay, the diagonal of the cube might go from that back corner all the way straight up to that front lower corner. It's going through the cube. So let's call that D on that diagonal, and let's call the edge length here X. Okay, in order to get X and D and how they're related, it helps to draw the diagonal of the base or of one of the sides. So that's the diagonal of the base. I can find its length by the Pythagorean Theorem because the base is a square, that's a right angle there. The side lengths are S, and that's the hypotenuse. So I'm going to sketch the base over here. Let's do a bird's eye view of the base. Keep the colors consistent here. Okay, so that's X, that's X. If you do Pythagorean Theorem on this, you're going to get X squared plus X squared equals, what should I call that? Let's call that C, equals C squared. So C is equal to the square root of 2x squared. And if we split that into two radicals, we get root 2 times the square root of x squared, which is x, since x is positive here. So we know that the distance of the diagonal of the base is equal to root 2 times x, and that's a relationship that you can memorize, that for a 45-45-90 triangle, or where two of the side lengths are the same, and it's a right triangle, the relationship is that the hypotenuse is always the square root of 2 times the edge length. Anyways, now we have a third triangle we can look at where this is the base, that's the height, and then this is the hypotenuse of this third new right triangle. That's still a right angle. So I'm going to draw this triangle that's going through the big cube over here. So that's the edge length S, that's the base, and then this is the diagonal of the cube. So the edge length is S, the length of the base is root 2 times x, and again we can use Pythagorean Theorem to find this edge length. So here x squared, that's this x squared, plus this leg squared, so root 2 times x squared is equal to the diagonal squared. So solving for D, we have D squared equals x squared plus root 2 squared is 2. So that's 2x squared. So the diagonal squared is equal to 3x squared. And that is a relationship that relates the diagonal to the edge length. Now we want to find the rate at which the diagonal of the cube is increasing if the edges are increasing at a rate of 6.6 centimeters per second. So you could differentiate this equation right here. And the problem though is that you'll have 2d times dd dt equals 6x times dx dt, and we don't know d or x. So it's helpful to actually keep simplifying and instead take the square root of both sides of this equation here, so that when we do differentiate both sides, we get something without d's and x's in it. Although you could still solve it even if we did it the other way. I think it's helpful to just keep simplifying. Okay, because the square root of d squared is d, and this will simplify to the square root of 3 times x. So that's a nice simple equation that I would rather use to differentiate both sides up, because the derivative of d with respect to t is dd dt. Square root of 3 hangs out, and the derivative of x with respect to t is dx dt. Then we can plug in the fact that its edges are increasing at a rate of 6.6 centimeters per second. So that means that dx dt is positive 6.6. So we just plug that in right down here, and you get root 3 times 6.6, or you could approximate that answer. And our units are in centimeters per second here.